Hello, everyone. Thank you for joining us today as we come together to learn more about integrating reactive APIs with your traditional databases. My name is Hassan Mohsine. I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft, partners, and the open source community. It's also home to the Microsoft for Startups program. With a diverse mix of hands-on workshops, expert panels, and community events, there is something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. Our speaker today is Rory Preddy. Rory is working in developer relations at Microsoft as a senior cloud advocate for Java. Cloud advocates use their deep research skills to help professional cloud developers discover and successfully use Microsoft's platforms. A seasoned speaker whose talks are both meaningful and humorous, Rory travels around the world, empowering developers to achieve more. Feel free to ask questions during today's session. We will have stops to answer these questions and also connect with us on Twitter. The hashtag is Reactor Abu Dhabi and MSFT Reactor is the Twitter handle. Also keep the chat open, the Q&A tab open, where I will be sharing some links and resources relating to today's session. And with all that said, I hand over the mic to our speaker to start the session.
Thanks, Hassan. I'm just going to share my screen now. So I add my content. It helps if I actually speak through what I'm doing because then I don't forget. So I'm going to share my content, add content from below. And oh, okay. So that looks like everything I need then. I've got the content. Hassan, you see everything? Good. Okay, great. Okay, so yeah, so this is wow, this is an interesting topic. I've done this topic a few times, and every single time I've done it, people have come to me and said, you've really made this simple to understand. And that's the point that I'm going to do. I'm going to show you how to connect to your database and use reactive systems. And I'm going to take you through a journey where you're going to learn the basics of reactive systems. And then you can start with a link that Hazem and I will give you that you can start with Cosmos DB on Azure with reactive databases using Java. Very simple. I know I like to think of it, if I can do it, you can do it. And all the slides are aka.ms/reactive-java. And this link here with this QR code will also be there at the end of the session. I do have, it's very demo heavy, so you'll see here, so don't worry about it. And then towards the end, we'll take some questions. Let's start with state of the reactive Java nation. Now, reactive hit the Java world really hard about 3 to 4 years ago, and people started freaking out a bit because they were like, is this going to replace normal imperative Java? People started creating libraries and frameworks, and the good news is that it hasn't. It hasn't really replaced what we understand as normal processing, but it has given you the option to choose whether you want your system to be reactive or not. And that's really what I'm going to show you today, between blocking and non-blocking, reactive and non-reactive, how to choose, when to choose, and how to actually engage with your systems in a reactive way. But we see the landscape is got many options to choose from if you want to go reactive. We have Jakarta EE and Quarkus, who both have reactive libraries. We have RX Java, the grandfather, the part of the RX family, including RxJS, RX.NET. Then we have JDK9 that included, and I'm going to give a nice demo on that, reactive streams. So reactive streams is actually built into the JDK as part of a core library, and we're going to go see how that works there. And then we've got Spring 5 with Project Reactor. I'm going to do a nice demo in there, and we're going to see how to do reactive systems all the way from the database to the front end. And then we're going to look at doing a nice little demo on Spring with Spring Boot, connecting to Azure. And I find it's a nice way to end off, because then it gives you some homework to do that you can go in and try it yourself. Defining reactive programming, and this is a nice little quote. Reactive programming is all about non-blocking applications that are asynchronous and event-driven and require a small number of threads to scale. Now, when reactive programming came to Java, and Java created functional programming lambdas, the need for that was really like this definition to scale, because when you scale with reactive programming in a functional way, you don't keep state. And if you don't keep state, if you scale horizontally across the cluster, you don't have to keep the state of the individual items, and you can kind of scale without having to worry about caching each of those individual items state. That's really the idea behind it, but it's a little bit more in depth, because there's four main properties to a reactive system, and you can go into reactivemanifesto.org. Let's go through them, and they list responsive, resilient, elastic, and message driven. So responsive, meaning that when it encounters change in load, it responds. And we're going to look at that with the demo in the Java 9 streams by looking at how back pressure works. Now, what back pressure means is that in case you're consuming data and you want to tell the publisher to either speed up or slow down, you're not managing to consume and you want to become more responsive, you push back to that publisher and you say, please, I'm not managing, here's a message to say either speed up or slow down. And that's really one of the key characteristics to be responsive as part of the reactive manifesto. Then resilient. And we've seen that with Kubernetes, with Docker, the drive for resilience. If your system goes down, there's a health check that you need to be able to give your system indication that your system's health is managed. Then elastic, being able to actually manage the elasticity of your system is to be able to grow exponentially outward. And this is really tied into the responsiveness also, because when you grow outward, you also, like I mentioned before, don't manage the state, or don't want to manage the state of all of those objects that when you elastically grow outwards. And then finally, message driven. Everything that a reactive system actually does is message driven, because even though you don't see the messages, it's using pipes and sockets to convey those messages through to the individual components of the underlying reactive system. So those are the four characteristics: responsive, resilient, elastic, and message driven. You can find out more information onto the reactivemanifesto.org. So if we know what the system needs to have, then what is reactive programming? So reactive programming has three main core components in the program. It has an observer, it has streams, and then it has back pressure. So an observer is an interface to notify an object that the next item in a sequence is watching is available. And we're going to see when we do the Java 9 streams example that the observer can also have a little bit more intelligence to say speed up, speed down, and become more responsive. Then you have the stream, and the stream is a controlled exchange of stream data across applications. And you can see there, this diagram that you see here is actually called a marble diagram. And I've simplified it because this is the simplest marble diagram you can get. They are pretty extensive if you want to go into advanced reactive system design. And you can see there that the observer in the stream is linked there as different marbles. And then you have the endpoint that the stream is completed. And this is important because when the stream is completed, your clients need to tell you, stop sending to me. If you don't have any more subscribers to a stream, why are you actually sending data? And that's also a part of back pressure. Back pressure is speed up, slow down, and also subscribe and stop subscribing. So observer, streams, and back pressure to control the flow of a producer and a consumer. Something we also need to define, which was kind of a buzzword for a couple of years, is functional reactive programming. So what happened when there was a lot of data being streamed is people realized that they could handle that data not via REST, but they could write the REST layer in a way that it was written in functions. We're going to go through a nice little example of that. But basically, instead of creating your normal CRUD REST features, create, read, update and delete, you could do everything in a functional way, and then you pair it with functions with the reactive programming. hence functional reactive programming. It's quite old. Colonel Elliott actually termed the phrase in 1988 in his paper Functional Reactive Animation, and he said functional reactive expressions describe entire evolutions of values over time, representing these evolutions directly as first-class values, which really didn't mean anything to anyone. And in hindsight, he said they stole this terms, because this was on animation to determine the state of an animation. And rather, what happened with functional reactive programming is that you can write your own REST layer. So in the example we'll give there, I'll show you how to do that, because it's pretty confusing. Because when you look at this Venn diagram, functional reactive programming, you've got imperative programming, functional programming, and then reactive programming, which kind of overrides the two there, and it gets a little bit confusing. But there's three main core characteristics of a functional reactive system or programming: compositionality. I think I got that right. Being able to compose functions, immutability, and guarantees inherent parallelism. So basically, being able to write a reactive system with functions. And this is a nice interview question. If you ever want to, stump people, please explain functional reactive programming. I actually have asked that in an interview, and I regret actually asking that. We'll go through an example of what functional reactive programming is. But let's stop for a second. Let's do some demos, and we're going to go through reactive basics. So we're going to have a publisher, a processor, and then a subscriber. And the nicest demo that I've actually seen of this is by thepracticaldeveloper.com, and I have got permission by the author to do this demo with you. And this is a nice, he's got a book on this called Java 9 Flows. And in this, he has magazine publishers, where the magazine publisher would publish to a subscriber, and depending on the speed of the consumption of the subscriber, they react differently. And we're going to give three demos and three different magazine subscribers, and subscribing to a magazine. Now, if they can't subscribe in time or consume in time, they tell the publisher, and then the publisher reacts differently, or they kind of indicate that they lost a magazine or didn't manage to actually get the magazine. So let's start the first demo. And I want to go to, I have learned how to Macintosh better than last time. And I've got the first demo. So this is Insider's edition of Microsoft Code, and I've cloned the repo. I haven't changed it at all. And it's called the Java 9 Reactive Flow, and I put the demo there. And it really has two files here. It's got the POM, which let's go through the POM here. It uses Java 9. And then it's got just logging, and that's about it. Then you've got the actual classes here. We've got the app. So let's go through this here. And in the app, we've got case one. So subscribers, the people who are going to get the magazines. Case one is subscribers are fast, and the buffer size is not so important in this case. And the buffer size is important because as you're consuming information, you want to put it into both the server has a buffer of how many magazines they're going to send, and the consumer has a buffer of how many they can actually process at any given time. We're going to send 20 magazines through, a max seconds to keep it when there is no space, in case the producer runs out of space. And so case one is subscribers are fast, buffer size is not so important at this case, and we're going to send it to that magazine example. Case two, a slow subscriber but good enough buffer size on the publisher side to keep all the items until they're picked up. So publishers are right on the buffer, but it's a slow subscriber. And then case three, a slow subscriber and a very limited buffer size on the publisher side. So it's important to keep the slow subscriber under control. So, and then we've got the actual examples for each one of those cases there. And you can see there that we set up the magazine publisher, print out the 20 magazines. We call our subscribers Jack and Pete. And then if we have an error here, we process those errors there if in case they're too slow. So if we do get if we do an offer and the subscriber actually sends back an error, remember back pressure, the subscriber will push back an error to say, I received I couldn't actually handle it, and back pressure back. Then the publisher will say, we received an error there. Would you like to slow down? I'll drop your magazine and you can do the next one. And that's really back pressure. And then we close it at the end of that. And then when the magazine subscriber actually gets it, he just says, I got the magazine, I got a new magazine, next one should be in the number, or there was an error and I missed the magazine because I was too slow for it. Remember, there's a time limit for that, so you can just run that there. So I can run it, and it's going to be quick in the beginning because remember the case one here, he's going to manage quickly, and then we're going to see right at the end the case 3 slope subscriber. He's going to trickle down into the magazine subscription. So let's run that. Let's go there, and we want to go magazine flow app. I'll make that a little bit bigger. Lots of colors. I love this colors. And we'll go back into exactly there. And you'll see here, so Jack and Pete are both subscribing. They offered the magazine up there to 20 magazine. Jack says, I'll get another magazine. He's on 2, 3. But you see there, Pete's a bit slower. And Pete's the case 2, so a slope subscriber. And then right at the end, we're going to do the last case, which is slope subscriber and also a low cache. And you'll see eventually they'll start to drop the magazines, and the server will start to process them in an error handling way, and we'll be aware that from the back pressure the subscriber is not managing. This is the basics of the principles. Remember, responsive, elastic, and what are those other 2 principles? Let's just wait for it to come back. So responsive, resilient, elastic, and message driven, because behind there's still messages going to and from between the subscriber. There we go. He says there, I got a new I think I just did this again. Let's go back there. They completed there. Okay. Oh, sorry. Case 3 just started there. So case 2 started. Finished and completed subscription, 20 magazines, and you can see there that Pete eventually caught up to Jack and did that. But case 3, which is the slow subscriber, still has to run, and he's probably going to drop those magazines. We'll come back to that eventually. But the core of this is that this is all message driven, and this is also responsive design, because you think about it, if you've got a mobile handset and you've got a tablet or a laptop, some of them might not have the bandwidth or necessary processing power, but it should be able to handle that. Okay, so it's completed there, and you can see there that 1912, so finally completed the subscription in that example with Pete. And he only got 15 magazines there, because that was the final case there, that a slow subscriber and a very limited buffer, he dropped 4 magazines, but he still was able to cater for his lack of speed. And this is an important concept and made famous by Netflix. So the Netflix banner that you get there, that shows you all of the available subscriptions, the core architecture behind that is always give the client something to see, even if it's just text. But you want to give them high definition to 1080p, then to 640p, then to text. And it depends on the subscriber on what they can actually handle. And this is really the 3 cases that we have there. This is based on the principle of responsive design and made famous by Netflix. So now we've got the demo. Let's go play from current slides. Now we've got the demo for reactive systems, and I've given you kind of a taste. You can go to Reactive book Java 9-flow, and you can play around with it yourself for the magazine subscriptions. But we're here because we're enterprise, to look at proper systems. And Spring 5 created the project Reactor, so you need Java 8+. It has netting now, which is a non-blocking web server, which is the out-of-the-box core server that Spring 5 comes with. It's got WebFlux, which is RESTful services using Flux and Monos, which will go through that. And then you can also, like I said before, you can use the classic MVC, or you can roll your own HTTP handling to do a proper reactive, functional reactive system. So with Azure, with Microsoft Azure, we cater for a lot of the different libraries, and with the Spring Data, which we're going to go through, we cater for Cosmos DB, and I'm going to do the demo in MongoDB style, but you can also do it in SQL database, MySQL, Postgres, MariaDB. It's a very vibrant Spring ecosystem, and Project Reactor with Spring takes a slice of the entire Spring ecosystem and says, okay, cool, now we're going to make it reactive. So you need to understand it takes request mapping, WebFlux, reactive streams, Netty, all of that, and gives you an opportunity to write your entire application using non-blocking. The first thing you want to do is you want to choose the database you want, and in this case, and the examples we're going to do, we've chosen Reactive Mongo, because Cosmos DB is actually Mongo, and you can use Mongo to non-SQL, and you can use the APIs of SQL or blob-based storage. So you create your interface, and I've done a demo of this before when I did my Azure Spring Cloud, but we're going to go through it again, and so you extend the Reactive CRUD repository, or your Reactive Cosmos repository, depending if you're using Azure or plain Mongo, and that's your interface. Then you create your REST interface, and you return the quote Mongo reactive repository.find all. That's pretty simple, and that's really Spring Data doing everything in the background, managing all of the responsiveness, the reactive libraries, everything in the background. And if you want to roll your own, and this is where it's interesting is, you can actually go and roll your own. So here's that same kind of service there. These are just returning quotes, and you can roll your own functions. So you can see there, the quote service would be having the repository in it there, and then you can kind of use functional reactive endpoints to process your requests in Lambda Java style, Java 8+ style, and that's your functional reactive REST interface there. Once you have it, you need a consumer, and the example that I'm going to do is using Angular, and Angular is great because it actually has built-in reactive processing. You can see there, I'm going to the URL string is localhost 8080 quotes reactive, so I'm going to get some quotes from a book. And then I'm going to use event sourcing to build in a buffer into my browser, and then push those quotes through a reactive library into the browser cache. So that's the demo, and so how do you test that? First of all, you can test it with Angular, with a Postman or a browser, but you can also curl. Now, when you curl, you're curling streams. You're not curling, you're not getting actual REST data when you hit a reactive endpoint, because you're getting a stream of data. And I'll show you how to do that. You can also use Web Client, these are new libraries, Web Client and Web Test Client, to kind of simulate your browser. So the next demo we've got, this is the full reactive stack from MongoDB all the way into Spring Boot and into Angular, from what we saw in how to do it. And I haven't done it with the functional reactive endpoints. I've done the standard REST endpoints because it's still reactive, and it goes from the data source, which is MongoDB, and it's a bunch of quotes, into the repository, which will bring back a flux, and a flux is just one or more quotes. That's what a flux is. Then the controller, the REST controller, will return to the customer those quotes, and then into the event source, into the observable, into the Angular framework, and then the component with the async pipe. And you can access all of this github.com, Machero, full reactive stack. It's a really nice demo, and there's a nice book affiliated with it. Okay, cool. So let's go. And once I've done this demo, I'm going to show you how to get started also from the start with MongoDB. But let's first see if I can get my demo working. I did have an issue earlier, but hopefully the demo gods are shining. So let's go and okay, so we need to do 3 things to get this demo working. So I need my MongoDB running. So I'm going to just make sure this is the project here, and it's broken up into a Docker, the Angular side, and then the Spring Boot side. So I want to first make sure that my Docker MongoDB is not running. Okay, cool. So let's start MongoDB, and this is locally. I'm going to show you how to do the cloud version after this, and how to get started with Azure, because I am an Azure advocate, so I need to show you some Azure. So Mongo only. I'm going to go compose up. using Visual Studio Code, and it's going to start the Docker instance there, and I can go check that Docker's running there. Eventually it'll come through, yay, Mongo's running, and I've got a Docker instance. And the nice thing about this demo is you can actually do the entire thing via Compose. But I want to show you how to do it from scratch. Then I want to go into my Spring Boot Reactive, and now this is where it gets very interesting. This demo is actually reactive and non-reactive. So when I go into my repositories, I actually have quote MongoDB reactive repository, and that extends reactive sorting repository. And this just returns back a pageable quote lists of quotes. And I've also got the blocking repository because I want to show you the speed difference between the two of them. I want to make that bigger. There we go. And so I've got two different files, and then of course, if I've got two different repositories showing blocking and non-blocking, reactive and non-reacting, then I need two REST controllers that also would be able to do that. And I've got quote blocking REST controller. You can see there quotes blocking, and this will delay it also because else it just streams too quickly and breaks my browser, and it'll go find all. And then I've also got quote reactive. And this is where, if you wanted to hit this, you can actually curl it, and we'll show you now how to actually hit that responsive. And I need to now go and start this up, this Spring Reactive system here, and I've already kind of set it up, and I want to just start, and hopefully it will start. I haven't got any port bindings that weren't bound before. Let's see, Netty started. So remember Netty, which is the non-blocking web server, started on port 8080. And I can test this right now, and that was pretty quick. And I'm going to go back into my how to test, because that's where my curl is. And I'm going to curl those responsive quotes. And I'm going to go back into my, there we go. I'm going to go back into my terminal here, make that bigger. Now I can curl, and I get my quotes. I get my stream of quotes. This is hitting the reactive quotes. This is the author actually did it in Spanish. I'm just getting a stream of data. This will be the same kind of consumption that a client would get if you were just streaming the data through. I want to close this now, Z. And the minute I do that, that Control Z, that's back pressure, saying to the server, stop sending me stuff. And you can see there, that's the curl, accept text event stream, and then quotes reactive. And that's how you consume it. But we want to do this with Angular. So going back to my application, I want to start up a new console. And I want to go terminal, new terminal, and then I want to go cd Angular, and I'm going to go ng serve. Now this should bind to port 4200. So my actual Spring application, of course, it's going to compile now, because compiling JavaScript is the new JavaScript. And localhost 4200, and I should be able to go command click, and here's my application. And now I've got this nice little application here, and it's going to bring back a list of quotes and then the quote detail. And I've got two little buttons here, reactive request and blocking request. Now, if I click blocking request, I can choose the page size. But blocking request, you'll notice here that it's going to take about 3 to 4 seconds because it's going to bring back everything in a bunch. And that's what we're used to do. And that's what our clients are used to seeing. So if I click on blocking request, and then it comes back. And that took about, 3 to 4 seconds. And I can click on that and it can give me the quotes, and you can play around with it also. But what happens if I click on reactive requests? First, I'm going to switch on paging off. And now watch the difference in mindset. And this when I first saw this was a pinnacle moment in my understanding of reactive systems, because I saw the measure and the value of it, though, to customers and to clients. Because when I hit that, it's instant. Not only is it instant, but it's still carrying on, and it's processing as fast as my browser can handle. And that's the difference really between reactive systems and non-reactive. I can hit blocking. No, I want to go refresh that. can hit blocking, it can wait for 3 to 4 seconds, and this is the norm that we were used to, and then it'll come down, and that's what you get. Or I can hit reactive, and it can start streaming through. And now this is just a consumer, a web browser, but you can think about web apps and data and stock prices and weather and just data. The internet itself, big data needs this. So yeah, that's the demo I wanted to show you. Now I want to show you how to get started, because obviously this is a prepackaged demo. I just want to close that there, Control Z, and stop that. But I want to show you how to get started from the start. This is a bit of a drum roll, please, because I'm going to do everything from start. And I have prepared the demo up front, so if anything doesn't go right, then we can actually just look at the completed. And this is on the Microsoft Docs site, Docs, quick start launch. I want to go R2DBC. So the team, the Java advocates teams maintain all of these quick starts along with the Azure teams. And we have demos here, and we'll put through here. And the demo I'm going to show you is the Azure DB starter reactive system. You can click through here, and it's going to go through all of these samples here, but I'm going to make it very easy and show you how to do that. But you can also get the Azure MySQL, Postgres, SQL database. All of this is reactive steps to start with that, and that's what I'm going to show you now. So the first thing I want to do here is I've got my project, and it's got my my skeleton of my user class, my user repository, my wingtip toys, and I even have an empty POM here. And now you can actually got a little script here. You can actually start off from the start by using curl. So you can actually curl the starter spring.io. So I'm going to do that. I know this is brave, hey? I'm just going to make sure. I'm going to go start.spring.io, starter.tz, dependencies, WebFlux, Azure support. The base directory would be the directory of this project, boot version 2.3.4, Java version 1.8, and then I'm going to unzip it into the local directory. So it's going to override everything that you see here. And yeah, this is brave stuff. And curl there. And there. So it put everything there. Now my POM should have stuff in it. And you can see there, it gives you your parent POM. It also gives you the dependencies, WebFlux, Azure Spring Boot, Spring starter test. But I just want to add one more library because we are speaking to Cosmos. So I want to actually go in and go POM. I want to go wingtip. Let's actually activate my snippet. So a little bit of a demo tip here, that you always snippet out your code. Don't type it out. There's not enough time to type it out. And you see there that the only thing I've added in my POM is my Spring Boot starter, which is an idiomatic way of connecting to Cosmos, and includes everything that we need to connect to Azure Cosmos. So let's go back in there. And now I need my, let's just delete that class there. I need my user class with something, with my Pojo. So plain old Java object. So I've got my class here. Let's just close that there. And I want my user class there. And I've got my user class, and it just has first name, last name, and string, and it's mapped through to a document in Cosmos DB collection, my collection. Now, I have created the Cosmos DB database beforehand. It takes about 7 minutes to create, and you can follow it through in the tutorial. It's pretty simple to create. Once I've got my user class, I'm going to create my user repository. So repository, and the user repository there just extends Reactive Cosmos repository. And then I've got my Flux with my users that I'm going to create. And these users are just Bob and Joe, and found by first name and then string first name. And this is a repository class. And this will bind with that library there. It'll try to find something in the application.properties linking through to the connection settings. Yeah, I know, black magic. Because you don't have to do anything else to connect to the database except for list some settings here. So let's do that. And I've got my Azure Cosmos DB. I'm going to delete this database afterwards because else you people are going to see my connection string. I've got my URI, my key, and my database. So when the repository actually starts up and binds into memory, it will find those settings. And then the last thing we want to do in my app here, obviously, I want to actually have a test class here to go and connect to my database and pull down all my user objects. So I've got my little my skeleton class here. So this basically it starts up, sets it up, clears the database, and then deletes it afterwards. It has an empty run method, which we're going to fill now, and then auto-wires my user repository. And it's a Spring Boot application. It's a command line runner. Pretty simple. So let's add that logic there. And the logic we're going to do is we're just going to create those users, and we're going to use a blocking style for a reactive system. Now, how that works, and I'm going to show you now, is that you can get a stream, but if you've received that data, you need a block, and that's that marble diagram. If you don't block, it doesn't understand that you need to stop sending the stream, and it won't actually finish the stream off. You won't get an end of stream notification. So let's add that logic there. Great. So let me make this a little bit bigger. And so we've got our users, and this is straight from the examples that you can use in that link with the Cosmos DB. I've got user one, which name is Tasha, and then it's going to say logging info, saving the user, and then I go save the user and repository.save. Remember, repository is that repository we just created, and it will return back a mono of those that user. And then obviously we want to see that that saved user is actually available. And the first time we use that user, now interestingly there, even though we've gone save, we haven't specified we want to use that object. We will only be able to use that object once we go block. And you can see there's the marble diagram there. So we want to go block. And it's the same as if you want to go find by first name, then you want to do block also. So when you retrieve your items, you want to block because you want to tell it that the stream is closed. So then we go find by user flux. So that's a flux of users. Find by first name, and that flux there. So yeah, so block there also. And remember, if you didn't want to block, if you just wanted a stream of data like Angular does, then you don't really have to block all the time. So yeah, then we save the users, and then we just look and query get first name, and we found those users. So let's run this now. And it's going to connect to my Cosmos DB database that I created online, and then it's going to create my repository from the connection settings, and then it's going to go save my users, clean the database first, save my users, and then it's going to find those users that I did save. So let's go save, run, and I want to go just click. I make this look so simple. Okay, there we go. It's connecting to the database service endpoint, and you can see they're getting database endpoint. It's connecting to my Cosmos DB database. This is very brave, live demoing with the reactive systems, clearing the database because that's what I did as part of the skeleton. Then it's going to create the user there, save that user Tasha. There we go. Netty started, saving user Tasha, saved user, find user by find ID, and it feels like a blocking system, but we've treated it as a blocking system. Remember, I said to you in the beginning of the session, you can write your reactive systems; they become part of your libraries, but that you don't have to write them in a functional reactive endpoint way. You can actually write them with blocking, and it becomes part and parcel of your normal imperative style of development. And that's really where the industry is heading. You can choose to be reactive or not, and you can also be reactive against classical databases, SQL, Cosmos, MySQL, Cassandra. All of these databases provide you with the ability to treat it as reactive or non-reactive and stream it through and change the way that your customers engage with your systems. Use back pressure to say, I'm a slow consumer, I'm a fast consumer, respond and speed up or speed down, and have that kind of responsive design and feel elasticity to your systems. And that's everything I wanted to show you today. Let's go back into our PowerPoint presentation. Play from current slides. Okay, so the pros: responsiveness, processing in batches, back pressures. So have your questions ready if you are, because we're nearly at the completion of the session. Resilient and elastic, due to back pressure and being able to control the consumption. Message-driven, reactive micro queues were controlling everything we saw in the background there. The cons, immutability. All of those objects, if they're responsive, they can't change state. So we need to look at using an immutable library to make sure that we don't change the state of the underlying objects. Debugging complexity. If you ever try to debug an Angular application, you understand with observables, it does become the chainable observable kind of debugging is pretty difficult. There's a steep learning curve if you're going to use reactive systems to understand how and what blocks. And then that also ties into, do you understand blocking? And this is a quote from his original paper. It doesn't matter if you use a reactive web approach in the backend. It won't be fully reactive and non-blocking unless your client is able to handle it well. Remember the case 3? They dropped 5 of those magazine subscriptions, didn't handle it well because it wasn't aware that of how to handle reactive systems. But are you catering for your customers and clients now? Do you have those 3 cases? Fast, medium, and slow? Well, you can with reactive systems. And so that's everything I wanted to show you today. To get more on the slides, code, and resources that I put through there, you can go aka.ms/reactive-java. Reach me on Twitter at Rory Preddy. And thank you, Hazem, for the opportunity to speak. And let's see if we have any questions. Hazem says I mustn't rush past the questions though, because it's like a 30-minute gap though. So if you do have any questions, let's take them in there and then we can ask you. This is a really complicated topic, so please try not to stump me too much if you do have any complicated questions.
Thanks, Rory, for today's session. And yeah, the floor is open for the community members to ask questions. The Q&A tab has some resources also for you that Rory mentioned. And as you can see, aka.ms Reactive Java is the link to use to access the slides and all the session resources.
So one of the things I did notice while we were waiting for some questions is that I thought, like in the beginning of my session, that reactive systems would take over imperative systems, that everyone would go non-blocking. It hasn't really happened. It has happened with observables on the Angular React framework. You know, the word React is actually on reactive systems. But from the backend side, I think with the databases, and this is why this talk was so important to me, the databases is the core blocking system. It blocks by the database. So if you can unblock the database, it's much easier once you've unblocked the database to go all the way back up to the custom. And we saw that with the full reactive stacks with those quotes. And so start on the database, take it in a reactive demo that I sent you, Cassandra, MySQL, SQL Server, Mongo, Cosmos, and then just try and look at how you can provide the blocking and the non-blocking opportunities for your customers. And what you'll find is that the speed increase is exponential, absolutely exponential, but like the learning curve also is pretty high. So let's see if we've got some questions. Nothing just yet. Okay, great. Thank you so much for joining me today. It should be on YouTube pretty soon. And we have also opened up a YouTube channel for the Java advocates. You can follow me on Twitter on @RoryPreddy, and I retweet those videos. We're interviewing Java champions and the Java ecosystem in and around Microsoft. It's a very vibrant ecosystem. We're also going to interview partners and product teams. So thank you so much, Hazem, and I look forward to seeing you on Twitter and in and around the Microsoft ecosystem.
Thank you so much, Rory. And I'm gonna start presenting just to share a few things with the community members. All right. Yeah. First of all, don't forget to give us some feedback about today's session and also about the sessions that you would love to see in the reactor. So the survey is for you to tell us about all the topics that you want, topics on DevOps, cloud development, AI, machine learning, and so on. Please use the survey to send us this feedback, and also use the session code on that survey. There is a special place for that. Today's session was has the code 8163. There are so many interesting sessions happening this week and next week. Please check out our meetup page on Reactive Abu Dhabi. On the calendar, there are a number of events and happenings and workshops that will be interesting for you to join. And also check out our YouTube channel. This is where you will get the session recording for today's session, and also different sessions from the Reactor team around the globe. This is for you also to watch it on demand. And there is also the monthly newsletter. We send that curated email. You need to be a member of the email list, so just use the Reactor email sign up to join that newsletter. It will mention all the interesting stuff that we're doing, the sessions and workshops. And just a quick reminder, the workshops that are happening on Mondays gonna be on Wednesdays going forward in October. It will be 8 p.m. local time. So this is a change on the calendar. And yeah, stay safe and goodbye.